Okay, I'm so sorry, the video is stopped at the first video, right? So we're going to continue here. 3 plus 4 is over with 2 is equal to 3.5. Okay, so this is 3.5, so this is your Q3. So your Q1 is equal to what we have just now. Q1, yes, Q1 is 1.5, Q3 is 3.5. Okay, so where do we got it? We got it from here. Just now Q3, you just calculate 33.75, right? 33.75 is somewhere here in between here. So the x that we're having is between of 3 and 4. That's why we are gonna have 3 plus 4 divided by 2 is 3.5. Here 3.5. So Q3 is 3.5, Q1 is 1.5. And then in the quarter range, it should be, it's not this one, okay? It should be, as for question C, in the quarter range here, of course we'll be having Q3 minus Q1, right? So we'll be having 3.5 minus 1.5, so therefore we'll be having 2. So I hope you are clear about this part. So let's proceed for the next one, which is about variance and standard deviation. Don't worry, you just need to follow this, follow the formula that we have here, which is, if we try to look at here, we are having a variance for a sample data and variance for the population data. To find standard deviation, we just need to square root of the variance, okay, square root of the variance, so you'll be having your standard deviation. Let's see for the example 5.4, the question given to you. It is given 20 observation of sample data given by we are having a sigma of x is equal to 3.16. Right, given to you, so you doesn't need to calculate. Sigma of x squared will be going to have 35.4931. Find the mean and standard deviation. Okay, so we know the mean will be having x bar, okay, or mean. It will be equal to 23. It will be equal to, so by following the formula we'll be having sigma of x, right, over with n. So in this case the n is equal to 20, right, and we are gonna have this one 23.16 divided by 20, it will be equal to 1.158. and for the standard deviation in this case we'll be using formula sample data. So we'll be having this one, standard deviation will be equal to sort of everything there, which is sigma of x squared minus with the sigma x and here squared, okay, over with n, okay, and then divide with your n minus 1, okay, which is in this case. So of course we'll be having here sort of everything 35.4931 minus with 23.16 squared over with 20, and here divide by 19, so we'll be having something like 0.4565 here, and approximately we'll be having 0.676. so I hope you are clear about this part. So in this case I'm using the formula for the sample data. Okay, you can see from here we have it to either population or sample, right? So I'm using the sample data here. The difference is what? The difference is denominator. The sample data we are having n minus 1, the population we are having n only. Okay, so let's proceed for the next one, which is for the group data. Group data, if you are having a bigger data, so it's very helpful if you are having a group data. So of course it will be related with a frequency distribution, so we need to learn on how to construct a frequency distribution first. I get a data, okay, so don't worry, we are going to see it together. Example 5.5, given to you record of construction company, age of the buyers are shown in table below. So you can see from here the n is bigger, okay, which is we have a large data here, okay, we have 60 data here. Okay, this is number of each. Okay, so we need to have some help, so we are going to construct a frequency table. Don't worry, this is just some examples, so you can try to do it later. Try to redo it until you get this table, this frequency table. So this is the class interval and number of bias, which is our frequency. It is a group frequency distribution. So we have a few steps or a few things that you need to know before we construct a frequency distribution. So frequency distribution is very helpful. You need to learn about it. Okay, about the class limit, the biggest and smallest value of class boundary, the size or the width of the data, class mark or the midpoint of the class. So we are going to call as a midpoint usually. Okay, so we'll be having lower limit, upper limit, midpoint, lower boundary, upper boundary. Okay, the first step on how to construct a frequency distribution. First, you need to choose a suitable class. Okay, number of classes, which is using the Sturge formula. First, you need to choose suitable class. Okay, how still number of class? How? By using Sturge formula, which is k is equal to 1 plus 3.3 log n. N is the number of data that can be used. Next, range of the set data, and then we need to determine the class size. How to determine the class size? We already have a formula: range divided by number of classes, and state the class limit. Okay, and then the next one, determine the frequency. Okay, so already say the important or the keywords. Okay, which is you can highlight by your own lah. Okay, example 5.6 on how can we construct a frequency distribution. So by looking over here, we have 40 newborn babies. 40 newborn babies. So by looking over here, okay, we are gonna have 3.0 kilo, 3.5 kilo, and so on, right? So there is a lot of babies here, a lot of data. So we are going to construct a frequency distribution table. So we know the number of data, the n is 40. So using Sturge formula, this is the first step. We are going to determine the number of class. Okay, suitable number of class. So using Sturge formula, 1 plus 3.2 log 40 is equal to 6.29. So approximately we can have 6 for this one. Nearest integer lah. So just round up, we are having 6. Okay, much easier to have our integer. And determine the highest and lowest value. The highest is 4.3, lowest value is 1.6 kilo. And the range, determine the range of 4.3 minus 1.6 is 2.7. And you need to know how the class size. The class size 2.7 that you have, which is the range here, divided by 6, it will be 0.5. We just need one decimal places, it's much easier. Okay, so it is 0.5. So having your frequency distribution, this is your class interval. So we are going to start with the lowest value. As you know, the lowest value in here is 1.6, right? So maybe better we are going to start with 1.5. Okay, 1.5 until 1.9. I know you are going to calculate in this way, is it right? The class size, number of class size. Okay, class size is 0.5. But if you know 1.5 plus 0.5 is 2.0, right? This is our logic, but I'm not sure how can I count, how can I show it to you, but I'm gonna show it by this way. We know that we'll be having 1.5, right? 1.5, and here's 0.5. 1.5 plus with a 0.1 plus with a 0.1 plus with a 0.1, which is actually 0.5 here. You are going to start count from here, which is 0.1, here's 0.1, here's 0.1, or I'm going to have it in this way maybe. Okay, this is start from 1.5 and here 1.6, 1.7, 1.8, 1.9. Here, okay, so we are going to start from here 1.1, 0.1, 0.1, 0.1, 0.1. So total up everything here will be 0.5, right? Will be 0.5, which is we are going to count from here 1.5 here. 0.1, 0.1, 0.1, 0.1, 0.1. That's why the highest is 1.9 here. I hope you are clear about this, right? Don't worry, we are having more example. I hope so that I can show you show it to you on how can we calculate in the right way. So this is one of the way lah, which is 0.1, 0.1, 0.1, 0.1. We are starting from 1.5 here. So I hope you're clear about this part. That's why our highest limit for the first for this class is 1.9. And then you count using the tally, so you can have the frequency. Okay, so maybe you can try to redo it again by having the steps there. Okay, so let's proceed. Graphical representation. Okay, for the graphical representation here, okay, before we are going to do to go to the graphical representation, there is something that I need to discuss with you, which is try to look over example 5.7. Example 5.7 here. I just want to know from you. I just want to know the class size for this table. Please answer it by your own first. Okay, so what is the class size? Is it 9 minus 5 is 4? It is not. It is not 9 minus 5 is 4. No, we are going to count it as this one. So 5, 6, 7, 8, 9, right? Actually the class size, okay, actually the class size for this frequency distribution is 5. How? This is 1, 1, 1, 1, and 1. We are going to count it as a 5, 6, 7, 8, 9, which means this is 1, 2, 3, 4, 5. The class size is 5. I hope you are clear on how can we calculate this one. So you can see from here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, which is the result is 5. The class size is 5. I just want to make sure that you are clear about the class size. Okay, so I'm going to continue about the graphical representation in the next video.